Newton's second law of motion. Example 1. What's the acceleration on this mass? So F resultant equals ma. So 80 is positive and 60 will be negative, so 80 minus 60 resultant force equals a mass times acceleration. So the acceleration is 4 meters per second squared, represented by this double arrowhead on a diagram. So we will have this resultant force, acceleration. It's a constant acceleration, which means we can use Suvat formulae for further problem solving, where a is a constant. Example 2. This mass is in free fall. Its weight will be m times g. The mass is 10, so it's 10g. We'll leave this in terms of g for the time being. So 20 newtons might be the air resistance. So F resultant equals ma, downwards direction is positive. So W minus 20 is the resultant force. Mass is 10. So the acceleration is 7.8 meters per second squared, downwards. Now acceleration is a vector, just like forces are vectors. So on a diagram, a force is given with its magnitude and its direction is given by the arrow. So together that forms a vector. For acceleration, we have magnitude and direction given by the arrow. Example 3. The acceleration is given, its magnitude and direction. So we have to work out the value of p. Downwards direction is positive, F equals ma. So 10g minus p is the resultant force, mass times acceleration. Now sometimes the acceleration value here can be a negative value because a is a vector. Now looking at my diagram, a is pointing downwards. I've taken downwards direction as positive, so that's a plus 5 here. And just solving, p is 48 newtons. Example 4. So we have forces acting in multiple directions, and I'm going to take horizontal forces first. So looking at the horizontal direction, and this direction is positive, x, and then minus 4 for the resultant force. The mass is 2 and the acceleration is 2. Look at the direction I've taken as positive. It's the same as the acceleration. So that will be plus 2 there for the acceleration, because it's in the same direction that I've taken as being positive. And then we solve. So x is equal to 8 newtons. Okay, so now looking at everything vertically, this direction is positive. So we've got y minus 2g. So we're resolving forces. There we go. Y minus 2g equals mass times. There is nothing to suggest in the diagram that there is any vertical acceleration. So the acceleration is 0, giving us y equals 19.6 newtons. Example 5. So let's start with looking at the horizontal direction, taking this direction as positive. So we've got 80 minus x there. 80 minus x equals the mass times the acceleration. And check the sign on the acceleration. I've taken this direction as positive. That's the direction of my acceleration, so this is positive. And that's a good way to pick the direction right from the beginning. Should I take the left as positive or the right as positive? You should stick with the direction of your acceleration to make things easier. And then solve. And now if I look at things in the vertical direction, if I take the downwards direction as positive, so then I've got 4g, that's downwards, plus 20, that's upwards, minus y. There. So the 20 plus the 4g minus y equals mass times, and the acceleration is 0. There's nothing in the diagram to suggest any vertical acceleration, so it's 0. And rearrange to work out y. Example 6. This mass is initially at rest, and there's a force of 20 newtons to the right, which is pulling the mass towards the right, and there's friction which is trying to slow it down, going in the opposite direction. And there's some acceleration here, so we will have a resultant force in the horizontal direction because we have acceleration in the horizontal direction. So to work out the value of the acceleration, this value here, F equals ma, I'm taking this direction as positive, so 20 minus 4 equals the mass times the acceleration. So A is equal to 3.2 meters per second squared. Again, that's a positive value for acceleration, and acceleration is a vector, so it has magnitude, which is this value, and its direction, because it's positive, will be the same as what we've chosen here, like so. Part B, what's the distance moved by this object in the first 4 seconds? So we know the acceleration was a constant, so this is a suvat problem now. So S is what we're after, that's the distance. Initially, the mass was at rest, so that's 0. We don't want V, so I've crossed that one out. Acceleration we have already, we've worked it out, and it's a constant, and t equals 4. So we need a formula without V, which is this one, and then just substituting the values in, and we solve. So the distance moved in the first 4 seconds, 25.6 meters. Part C. To work out the normal reaction force R, we can use one of two methods. The first one is Newton's second law, F equals ma. Taking this direction as positive, the resultant force is R minus 5g. The mass is 5 kilograms, but what's the acceleration? There's nothing in the diagram suggesting any vertical acceleration, so A equals 0. A equals 0, and then we solve. So vertically we have no acceleration, so we've got R equals 49 newtons. The alternative is to use Newton's first law. Now we use the first law where we have balanced forces, where there is no resultant force. And looking at the forces vertically, the forces are balanced, there is no resultant force. So starting off with F resultant equals 0, the upwards direction is positive. So R minus 5g is 0. So we know that R is equal to 5g. Any upward and downward forces are balanced, so upward equals downwards, R equals 5g, like so. And R equals 49 newtons. For practice, try these questions.